Thank you very much for watching this video. My name is Salam Ketab. I am a PhD researcher in Plymouth University, the United Kingdom. My research title is E-Invigilation of E-Assessments. Introduction. E-learning and particularly distance-based learning is becoming an increasingly important mechanism for education. Whilst a range of virtual learning environments, VLEs, now exist to facilitate this, there are some significant limitations when considering the assessment options that are available. The lack of being able to provide invigilation in a remote mode has restricted the types of assessments, with exams, or in-class test assessments proving difficult to validate. This project seeks to research and develop an e-invigilator that will provide continuous and transparent invigilation of the individual undertaking an electronic-based exam or test. The main objective for this research is to explore, propose, and evaluate a multi-biometric profiling approach which enhances the security for the e-assessments. In prior literature, the number of suggested solutions to minimize the cheating behaviors during the online test have varied and can be categorized as following: human proctoring systems, biometric-based solutions, including single and multi-biometric systems, video monitoring of student, biometric authentication and webcam monitoring, commercial solutions, and software and hardware solutions. However, no one of suggested systems, prototypes, or schemes described in the literature thus far can play the role of robust, transparent, secure, feasible, applicable and continuous authentication system to be a satisfactory alternative. This encouraged us to focus our efforts to design and develop a more effective e-invigilation system. The system should have the ability to monitor students using the most efficient biometric measures. The system should be secure against external and internal threats. The system needs to be scalable to manage the storage, retrieval, and processing of biometric samples. A system that is flexible to enable it to adapt to new monitoring and biometric technologies. A system that is user-centric, through the application of HCI principles. Therefore, a core framework for an e-assessment system has been developed based upon maintaining student convenience but providing effective verification of participants throughout the test, rather than merely at the beginning. Transparent or non-intrusive identity verification is utilized to conveniently capture and process biometric signals, which has the potential to facilitate continuous verification. This novel e-invigilation system is designed in a modular fashion to incorporate a range of behavioral and physiological biometrics including 2D facial recognition, 3D facial recognition, mouse dynamic analysis, keystroke analysis, eye movements, head movements, linguistic analysis, and iris recognition, This range of techniques provides an opportunity to capture biometric samples under a range of differing examination scenarios. The key to user acceptance is usability, and the system has been designed to specifically ensure ease of use for all users. Prototype. In order to highlight the ease of use and lightweight nature of the system, a prototype was developed. The subsequent slides will describe the operation of the prototype with respect to the two key roles, academic and student. After entering his or her username and password, each academic will be recognized according to the information in the directory entry and redirected to a general page. Once the academic logged in, there are 5 tabs available. The first tab from the left side of the menu bar contains the system general rules. Then, 2 tabs provide the ability to create and edit exam. Then, a tab to review the taken tests, and the last one for help, which includes further sub-tabs, about, and contact, in addition to the logout link to provide the ability to log the academic out. To create an exam, the lecturer must complete the fields as shown in this figure. The academic uses a name to differentiate between his or her tests, typically the module or assessment title. The start and end timestamps and duration can be used to enable the academic to either restrict a student from taking an exam until a predefined slot, or alternatively, the academic can set this up so that the student is able to undertake the exam at any point between the 2 dates. To edit this test, the academic can click the blue cross in this interface. If the academic would like to edit, delete, or even create a new test, then he could click the Edit or Create Test tab. This will lead to view a page as illustrated in this figure. The academic can also create, edit, or even delete tests through this page by clicking the pencil icon beside each of created tests, and this will lead the academic into further inner process that require to recall the same test creation page with the last setting as shown in this figure. Furthermore, the academic can add new test from here by clicking this blue cross. A management interface is also provided to the academic in order to aid the examiner in understanding, managing and accessing their assessments, obtaining an overview of all current and previous assessments that have been defined during any particular academic year, and review or check the biometric results of each student. Student system. The principle of ease of use has given a high priority in this part of the system. The system provides many simple windows with clear instructions. Many tabs can be used by student, including student instructions, enrollment or even re-enrollment. Via My Tests tab, the student can easily see all his available tests. This diagram illustrates the general student system processes. The system offers a continuous user identification employing multimodal biometrics, namely, 2- and 3-dimensional facial recognition. In addition to security layer using eye movement, head movements, speech recognition, and recording surrounding sounds. The focus of this system in particular is the development and evaluation of 3D facial authentication. An experiment has been conducted to investigate the ability of the proposed platform to detect any cheating attempts. During the experiment, participants' biometric data including 2D image, depth image, infrared image, left and right eye images, eye movement or focus on the screen, and head movements, have been collected using custom software. In addition to capturing facial images, the 3D camera also captures the session using a built-in microphone with noise cancellation, and the system recognizes speech, employing a speech recognition algorithm. In system implementation, in order to register or access the system, the participants work through a process of registrations where the system will collect their face images template data. It also provides the ability to calibrate the basic eye movement around the screen. In this process, only a legitimate user should be involved, so the academic needs to perform a check using the university enrollment data. After registration, the student can log in the system and then he will face a fully monitored online assessment interface. The above part of the screen shows the live face and eyes images in addition to all system parameters. This can be hidden by clicking the Hide Preview button. The lower white part is the online assessment space. After clicking the Start Test button, a continuous user identification using 2D facial recognition sub-algorithm will be continually enabled during the first 5 minutes of the online assessment, and their facial features will be compared with the information in the database. The samples will be taken and saved every 4 seconds. With every successful matching, the system stores the taken sample to measure the 2D FRR. With every matching failure, the system stores the taken sample to measure the 2D FAR. Due to the fact that the camera can only operate in either 2D or 3D mode in a specific time, after the first 5 minutes of the online assessment, the system will change the mode to continuous 3D face identification for the remaining 10 minutes of the test. All facial features will be compared with the information in the database. The samples will be taken and stored every 4 seconds. With every successful match, the system stores the sample to measure the 3D FRR. With every match failure, the system stores the sample to measure the FAR. The eye tracking security subsystem is continuously running during both 2D and 3D modes. The tracking results, the captured photos and all left, right eye movements and center locations, about 30 samples every second, will be stored in a text file, for later analysis. The continuous audio recording subsystem, and the textual representation of grammars for use in speech recognition, or Java Speech Grammar Format Algorithm, JSGF, will be run during both 2D and 3D modes, and the recognition results, times, and durations will be saved in the system database. The head movements, roll, yaw, and pitch, will be measured continuously during 3D mode only, and the measurement values, about 75 samples every second, will be saved in a text file. Results: 51 participants participated in this experiment with an FRR of 0% in 2D facial recognition mode and 0.0063% in 3D facial recognition mode. The results are shown in this table. Some consequence participants' results, particularly in 3D facial recognition mode, contain 1 to 14 of 146 rejected samples. This would be due to some hardware or connections failure during the experiment. In order to evaluate the robustness of the approach against targeted misuse, 3 participants were tasked with a series of 8 scenarios that map to typical misuse. The 8 predefined threat scenarios are: leaving the location, using the interfaces such as keyboard, mouse, or the laptop mouse pad by somebody else, providing unauthorized help by answering the questions by another individual orally, fixing the camera and the eye tracker in front of the exam taker and moving the computer to another individual, turning the head and looking for unauthorized help, using a photo of a legitimate student in front of the camera, using a photograph as mask, and another individual pretending to be a genuine exam taker. This table summarizes how the system dealt with the previous 8 scenarios, and this table presents the results of the FAR and FRR of the first, second, sixth, seventh, and eighth threat scenarios, which are repeated with 3 participants in both modes. The results were zeros for all cases except the FAR of the 6th and 7th scenarios were 0.11 and 0.076% respectively in the 2D facial recognition mode. This table shows a detailed data sizes. In terms of the operational aspects, the required space on the disk was very satisfactory. In return to the academic subsystem, if the academic would like to show the results of the invigilation, he can click the Show Authentication Results tab in this interface. Then, he should choose module name, session number, test name, student name, and finally, click View Result. The system will show another interface to show the authentication and security results. The green rectangle around the photo means there is no problem during this period. The yellow rectangle around the photo means there is a security problem during this period, such as eye tracking or speech. The blue rectangle around the photo means there is an authentication problem during this period, such as no face or even another face in front of the camera. The red rectangle around the photo means there are both security and authentication problem during this period. The academic can navigate to show more results, and listen to the entire recorded sounds during the exam time. To show all the captured photos, the academic can click on the same photo. Here he can see more details that help him to deny or confirm cheating. The academic can also navigate to show more results, or even listen to the short recorded speech. If the academic confirmed someone cheated, then the system will provide a report of that cheating as accessible evidence. And finally, I would like to thank you so much for giving me this opportunity and support.